you can have a play with this simulator. So this is on the PhET thing, and I'll give you a link to this, and you can have a play with it. So what we've done so far, this is a laser pointer that I'm moving around. I press the red button, it turns it off, and I press the red button, it turns it on. I can change this from to different colors of laser light. Here I'm changing the actual wavelength. Here I'm into a very short wavelength of 400-ish nanometers, and the light is a purpley color. And if I go into the red, I get into the longer wavelengths. Okay, this is the visible spectrum. Past the red, we get into the infrared, which a lot of your remote controls will use. Again, we can't see infrared. And then past the violet end, we get into the ultraviolet, which is the wavelength of light that gives us a sunburn or causes a tan and things, causes freckles in me. Okay, I can go for many beams of light, or just have one. And currently the white background is set to air. I can change it to water or glass, but I'm just going to leave that as air. Down here I've got a selection of prisms. I've got a triangular prism. What's that called? Can't remember. Is it trapezium? Yeah. But we've been using these square ones. Okay, that's what we used last. And let's just get this. Oops, get it going straight across. So if I put my prism straight in, the light goes straight through. So this is a glass prism. I can change it to water or air, but I'm going to leave it as glass. And you can see that the light just goes straight through. It's not bending it because it's hitting it at 90 degrees. It's hitting it at the normal. But if I start to rotate the glass block, I start to bend the light. So when the light hits the glass surface, it slows down, and therefore it bends it, it refracts it, and then it carries on straight through the glass. It's not refracting through the glass, it refracts at the surface, and then it refracts at the other surface, and then the light ray going in is parallel to the light ray coming out, but it's shifted. Yeah, we have refracted the light. Okay, and I can move this around and see the effect and get 3 lasers going. I'm going to try and split off one of them. Look at that, I've got, yeah, so why is that doing that? You can have a real play with this. Okay, so that's the lasers. Okay, what I want now is to have a white light. So this is now producing white light, and to fully appreciate it, I've gone for a black background. So let's put it up here. So I've got the maximum kind of movement, and I'm going to try and split the white light into its spectrum. So here the easiest way to do this is to use a triangular prism. You see lots of images on the internet or just in textbooks where they've done this experiment, and it's one that we're missing out on, unfortunately. But if I put this triangular prism here and I maneuver it round slightly, let's move this to there. In fact, it's just not quite where I need it. There, we can see it now. Yeah. So when I have this hitting the glass prism at an angle, the triangular prism, it refracts, and then it refracts in a different way when it gets to the other surface. Okay, and therefore I'm kind of like doing double bending of light, and the longer wavelengths of light refract less than the shorter wavelengths of light. So I start to get, as you can see down at the bottom right hand corner, you can see I've got the all the colors of the rainbow. I'm trying to get more splitting. So you can see there I've got more splitting by changing the angle slightly better. Oops. Oh yeah, that puts the normals on. If you want to press the normal button, that just shows the reflections you get, because glass is shiny and therefore you get reflections. I'll show you that in a minute anyway. But you can see how that I've got that. If I just move it over here, that's far clearer. So yeah, the red part of the spectrum is bent less than the blue end or the violet end of the spectrum, and therefore I've caused the white light to be split into its bits. And you can have a play with this. Yeah, I can get a triangular prism there. What happens if I put another one in? Can I actually separate out? Can I actually split the light so that I get, oh look there, yeah, I can. I've split off the red yellow and green from the blue by the looks of it. Oh, but yeah, I can actually split off different parts of the light by having another one here. Maybe I don't even need another one. Maybe I can just do that with this one. Just get it right on that corner. Is that going to cause it to happen? No, maybe you do need two. Okay, so yeah, it's something that you can have a play with. Can you split the light into its spectrum and then turn it back into white light again? Yeah. So again, something like, have I managed to do it there? Oh, possibly. I can change the angles by just hitting the rotation bit where you can see there. So let's just go back while I've got it up onto what we've been doing about, so it's nice and clear. So yeah, put on a rectangular prism. Let's go back to a white background with a red laser. It goes all the way through. Put on my normals, and it's quite boring. But as soon as I rotate this, you see how the normal lines are at 90 degrees to the glass surface. So when the first red laser beam hits the glass, it bends towards the normal. And then when it comes out of the glass block, it's bending away from the normal. Okay, so remember we talk about angles of reflection and angles of refraction. Here we talk about angles of refraction. If I put on reflections onto it, you can see how it starts to get a lot more complicated. Let's just remove that from here. So I'm starting to get a reflection right wherever it hits it, and I'm getting internal reflections as well. Again, these are less red, and therefore they'd be lighter. There's a cat making a noise on some paper, so I'm going to stop there. But hopefully that's something that you can have a play around with and try and understand how light affects with different types of prisms. And these, that's the kind that we use for glasses, as is this one here. I'm starting to get a jumble. Try and keep it simple, but yeah, have a play with it. It's what science is about.